Hello, Mr. Lee. This is my math video essay. I'm going to explain the development of the IRC formula using limits, and my name is Sarah Hagani. So first of all, you can see that I have a parabola drawn here and a point on my parabola, a f of a. To start, I'm just going to draw a tangent at this point. So a tangent is meant to show the behavior of the curve at a particular point, in this case a f of a. So I'm just going to try to draw the best tangent that I can right here with the black line, and the slope of the tangent at this point corresponds with the instantaneous rate of change that we have talked about. Now that I have my tangent drawn, I am going to pick a second point and draw a secant line by choosing a following interval. So a following interval is supposed to be on the right side of my chosen point, so I'm just going to pick this point for 0 as my second point and connect my initial point and my second point in order to have a secant line. Now, this interval, the difference in my x values between my initial point and my second point is called h, because it is basically the distance. And we put h here. So this is my following interval, as I said. And if this is my a, this second point, x value for it will be a plus h. Consequently, the y value will be f of a plus h. Now that I have my secant line drawn, I'm going to develop its the slope of the secant line. So the general formula for slope is y2 minus y1, so the difference in y, and x2 minus x1, delta x. This is basically the slope formula for the 2 points that I have. Now I'm just going to substitute what I have on the graph into this formula. So my y2 is simply the y value of my second point, which is f of a plus h, and the y value of my initial point, which is f of a. I'm just substituting, and then the same happens for the x values. So the x value of my second point is a plus h, and the x value of my first point is a. You can see that the a's cancel out beautifully, so I'm left with h in the denominator. So I'm just going to erase this part so you can see the final formula for the slope of the secant. Now that we have the slope of our secant, let me go back to my graph. And okay, so what if we want the secant to approach the tangent? How does that work? Well, simply, we already talked about the distance between the first and the second point is h. So in order for the secant line to approach the tangent line, the interval between these two, or the delta x, has to decrease. So basically the h should approach 0. As the h approaches 0, you can see that this point will slowly approach the tangent line. I can show this by drawing it. So it will slowly approach the tangent line as h approaches 0 but never reaches 0. I can also explain this algebraically. So the slope of the tangent formula will do the same thing for us. And it is the limit as h approaches 0, same as we said, of f of a plus h minus f of a over h. Notice that the slope of the tangent formula, this part of it, is exactly the same as the slope of the secant formula, except this is the limiting value. And h has to approach 0 in order for the secant to approach the tangent line. And I just wanted to add that this is because the slope of the tangent is the instantaneous rate of change, while the slope of the secant gives us the average rate of change. That is why we have the slope, so we just substitute the values for the initial and the second point in the slope of the secant formula. But for the tangent, we had to use limit and h approaching 0, not just the slope. Now, looking at the slope of the tangent formula, I can also consider a preceding interval, not just the following as I did on the graph. So a preceding interval, the difference with the following interval is just that the value, the second point, is on the left side of the graph, and we've done of the point on the graph that we have chosen, and it is going to be another secant line. So this is my initial point. If I want to pick another point, I would simply go for this one. It doesn't really matter as long as it is on the left side. And you can see that I have a second secant. I'm going to draw it with a black so it's clear to see. And looking at this second secant, it is exactly the same. So if I have a preceding interval, as I do here, this is also going to be an h, which is the distance between these 2 points, between their x-axis, between their x values. And also, as the h approaches 0 for this secant line is going to approach the tangent line, just as it did with this other point. So h approaching 0, the x value decreasing, and you can see it is approaching my tangent line. What I mean is that the second point I've chosen for drawing a second secant, if you look at the slope of the tangent formula, you can see that it clearly considers this interval as well, because there is no difference. This is a plus h f of a plus h. Well, this can be the second a plus h f of a plus h. I just haven't substituted the exact values for a, but it is basically the same. It is just on the left side of my initial point. This is on the right side, so this is following, this is preceding interval. Now, in order for a two-sided limit to exist, the left limit and the right limit should both approach a common point, a common value. So here you can see that I have this IRC formula. And in order for this to exist, two-sided, the following interval should have the same value as the preceding. And we saw here that this happened, so a tangent line existed. We saw that our following interval and our preceding interval both approached a common value, a f of a. Now I have another example which is a bit weird from what we saw, a bit different from what we saw. And in this example, you can see that there is a discontinuity in the excuse me, function. On this graph, again, I have f. Let's take a look at this function here. Is this a two-sided limit? In order to understand why a two-sided limit exists, we have to look at the IRC formula. If h approaches 0 from the left side, if we get the same value, common value, for h approaching from the right and left side, then that means we have a two-sided limit. If we look at my function here, I have chosen an a, which is 2, but for this function we can see that there are actually two f of a's for one a. And then what I've done is I have picked a second point on the right side of my function for the following interval, and another point for the left side of my a, which is demonstrating a preceding interval. And I have just drawn secant lines. Now I want to show you the secant line approaching a tangent line, and the tangent line at A. How would that look like? Because here we will have two tangent lines. One tangent line here for for A, and another tangent line will look like here. So how does that work? If we consider h approaching from the left side, you can see that this secant line will approach this tangent line from the left side. It is approaching this tangent line. And let's say there's some value for the slope of this tangent line. We're not doing calculations here, just looking at the graph. And if I'm approaching h is approaching 0 from the right side, this secant line will approach this other tangent line. So what you can see is that these two tangent lines at A, not only they have different slopes, and you have different f of A values for 1A. There's a discontinuity. Therefore, there is no there is no tangent, there is no instantaneous rate of change at A here. Because, let's say if I were to draw a tangent at A, how would I draw it? Would it be like this, a vertical line connecting these two? Well, let's say if I draw a vertical line, this doesn't look like a tangent, like you wouldn't think there's such a huge gap. And even if we say this is a tangent, it's clearly not, because if I have a line that is vertical like this, the slope is going to be 0 over 0, and the slope of 0 over 0 is undefined, as we know. So even if my secants were going to approach this tangent line, the secants are going to approach it, like it's not even possible to approach that 0 over 0. So at A, we can see on this example that even though a left-sided limit exists, a right-sided limit exists, but the instantaneous rate of change formula fails and does not work. So there is no tangent at this point. So you can verify for yourself. This was made by me. Thank you, Mr. Lee.